Let's talk about producing data. There's two basic methods for producing data. One is through an observational study and the other is through an experiment. In an observational study, you observe individuals and you measure characteristics of interest, but you do not attempt to influence the individuals. In an experiment, on the other hand, you're going to deliberately apply some kind of treatment in order to measure the response to that treatment. So here's an example. The Nurses' Health Study has interviewed a sample of more than 100,000 female registered nurses every 2 years since 1976. The study finds that light to moderate drinkers had a significantly lower risk of death than either the non-drinkers or heavy drinkers. The Nurses' Health Study is, and we need to choose between observational study, experiment, or uncategorizable without more information. And in this case, what we're looking at is an observational study. So this one's an observational study because all they did was interview these nurses. They didn't apply any sort of treatment to them. They're just observing them through the years. So remember, one of the key differences between observational study and experiment is that in an experiment, you can use your results to show a cause and effect relationship. Whereas in an observational study, you have to be really careful. There's often lurking variables in observational studies, so we cannot prove a cause and effect relationship with with an observational study. All right, let's look at this example. What are the effects of repeated exposure to an advertising message? The answer may depend on both the length of the ad and how often it is repeated. To investigate this question, assign undergraduate students to view a 40-minute TV program that includes commercials for digital camera. There are 3 versions of the commercial: 30 seconds, 45 seconds, and 60 seconds. For each version of the commercial, some subjects will see the commercial once during the program, and others will see the commercial twice during the program. After watching the TV program, all the subjects fill out a questionnaire that produces an intention to buy score with values between 0 and 100. So first question is, what is the response variable? The response variable is what you're measuring and in the experiment. So in this case, our outcome, what we're measuring, that is going to be this intention to buy score. So the response variable is intention to buy score. All right, next question. How many factors are there? And we can kind of see the factors right in the very first second sentence here. It said the answer may depend on both the length of the ad, that's factor number 1, and on how often it is repeated. So those are the 2 factors that we're interested in. We're looking at how long the advertisement is and how often the subjects are going to view this ad. So when we talk about how many factors there are, there's 2. The 2 factors are length of the ad and how often the ad is viewed. So how often viewed. Now, these are the variables that we're looking at. But in order to actually execute the experiment, then we have to choose specific levels of these factors to include in the experiment. So for the length of the ad, they looked at 3 different levels. They looked at 30 seconds, 45 seconds, and 60 seconds. So the factor length of the ad has 3 levels, which are 30 seconds, 45 seconds, and 60 seconds. For our other factor, how often it's viewed, it says that some people will see it once during the program, other people will see it twice during the program. So for the factor of how often the advertisement was viewed, it has 2 levels, once and twice. So next question says, how many treatments are there? So in order to determine how many treatments there are, we take the number of levels for each factor and we multiply them together. So we back up 1 page. We had 2 factors. One of those factors had 3 levels. So we'll say 3 levels. The other factor had 2 levels. So when I'm determining how many treatments there are, I'm going to take 3 times 2, which gives me 6. So there were 6 total treatments in this experiment. And I often get the question, what's the difference between a treatment and a factor? The treatments are what we're actually applying to the individuals. So in this case, treatment number 1 might be seeing the 30-second commercial 1 time. Treatment number 2 would be seeing the 45-second commercial 1 time. Treatment number 3 would be seeing the 60-second commercial 1 time. Treatment number 4 would be the 30-second commercial but seeing it twice. So these are the actual things that we're applying to the subjects or to the experimental units. So we have 45 seconds and twice, and then the 6th treatment would be 60 seconds and twice. All right, this is an example of how to use Table B, and in the interest of time, I think I'm going to skip this one. I'll try to come back and do this one in a separate video. So the next 4 examples are some different scenarios, and we're going to look at these scenarios and decide what type of sampling design or what type of experimental design that we're dealing with. So here's the first one. A firm wishes to survey a sample of a large company's employees. The company has 100 managers, 1,000 laborers, and 300 engineers. They randomly select 5 out of the 100 managers, 50 out of the 1,000 laborers, and 15 out of the 300 engineers to be in the sample. Okay, so first off, we need to decide between if we're looking at a sampling design or an experimental design. So we need to decide if this is more of an observational study or if this is more of an experiment. And in this case, we're dealing with an observational study. We have all the employees in this company, and we're trying to select some of those employees to participate in our survey. Okay, we're not going to be applying any kinds of treatments. So first thing to note is that we're looking for a sampling design because it's not an experiment. And there's kind of 3.5 different sampling designs that we can look at. We can look at a simple random sample, a stratified random sample, a systematic random sample, and a voluntary response sample. So we're choosing basically between these 4. So let me just describe each of those, and then we'll decide which type is for this particular example. So a simple random sample means you have everybody in the population, and you're basically drawing names out of a hat. So you take everybody in the population, and you're randomly selecting some to participate. In a stratified random sample, we have everybody in the population, but before we do any random selection, we're first going to divide the population into groups of similar individuals. Once we have the population divided into groups, then we're going to randomly select individuals from each of those groups to participate in our study. So stratified, we group first, then randomly select within the groups, and then we put all the sample back together. A systematic random sample, this one uses an interval method for sampling. So let's say we're going to sample every 5th person that walks out of the grocery store. We would still use randomness to decide which of the first 5 people was going to be our first person in our sample. So we'd maybe use the random number table to select. Once we had that first person, we're going to sample every 5th person that walks out of that grocery store. Okay? Or, you could sample every 10th house on the block or something like that. A voluntary response sample, the first 3 of these, simple random, stratified, systematic, these are all good sample designs because they use randomness in some way, which is impersonal chance to select the sample rather than a non-random method. So a voluntary response sample is actually a bad sample design that employs a lot of bias in the way that it's set up. And the reason why it's biased is because it doesn't use a random method to select its sample. Instead, there's some kind of broad appeal, and anybody can choose whether or not they want to be in that sample. So if you're watching TV and they say, hey, we want to find out what people in Austin think about the new toll roads that are going up all over, go ahead, call 1-800-I-LOVE-TOLL-ROADS if you think that they're great. Dial 1-800-I-HATE-TOLL-ROADS if you think that they're not great. then this would be an example of a voluntary response sample. They're putting out an appeal, and anybody who wants to, that hears the appeal, can go ahead and participate in that survey. Things like most online surveys are more of a voluntary response type. You know, if you go to a website and off in the corner it says, hey, will you please fill out our survey here? Well, it's basically just putting out this appeal to anybody that comes to their website, and somebody has to choose themselves to be in that sample if they want to go ahead and select to do that. The problem with that is that people usually don't want to participate in those surveys unless they have a really strong opinion one way or the other. So that sample is not going to be representative. So the voluntary response one is bad. If we're using randomness to select the sample, it's not going to be this voluntary response one. All right, back to the problem at hand. In this case, what we have is a stratified random sample, because we first took the population, which was this company. We divided it into groups of like people. So we had the 100 managers, we had the 1,000 laborers, and the 300 engineers. And then we took a sample from each of those groups to form our final sample. Here's another example. A statistics teacher wants to know if there is a difference in taste between dry or slow-churned light ice cream and Bluebell light ice cream. She has 30 students who are willing to help with the study. Each student tastes both ice creams whose identity is disguised. A coin is flipped for each student to determine if they will try cup A or cup B first. All right, so first thing we have to decide, is this a sampling design? Is it an observational study, or is it an experiment? So we're looking for an experimental design. It's going to be an experiment if we have some kind of a treatment that we're applying to individuals. So that's going to be the case for this one. In this case, we have a treatment, the ice creams, that we are giving to these subjects. So we're looking for experimental designs. There's 3 basic experimental designs. There's a completely random design. There is a block design. And there's matched pairs design. All right, so let me talk a little bit about the difference between the 3 of these. And again, the difference between these different designs goes back to the randomization. So because it's an experiment, we have all of our subjects or our experimental units that are going to participate in our study, and we're trying to figure out how to assign treatments. So that's where this randomization comes in. So in a completely random design, you have all the people that are going to participate, and you take all the people and just randomly assign them to all of the treatments, completely random. The second method here is a block design. So in a block design, we take all the subjects that are going to participate in our study, and we first separate our subjects into groups of like individuals. Separating them into these groups is not the treatment, and it's not random. So for example, we might think that men and women might be, men might be similar to other men in their preference for ice cream. Women might be similar to other women. So maybe we decide we want to block on gender. So before we start the experiment, we would take our 30 students and we would separate them into men, separate them into women, and then we would decide what treatment, decide the treatments, if this was a block design. So in a block design, you not randomly separate them into groups or blocks, and then within each block or within each group, then you randomly assign the treatments. So the third one here is matched pairs. This is actually a specific type of block design. Instead of dividing people into groups, we're actually pairing up individuals that are as alike as possible. And then we're going to randomly assign the treatments within each pair. So in a matched pairs design, you can only compare 2 treatments because a pair is only going to be 2 individuals. And kind of a special case of a matched pairs design, you can actually have one person that's considered to be a pair that would receive both treatments but in a random order. So back to this particular example, this one would be a matched pairs design because the student is going to be the pair and the randomization is happening within each student or within each pair. So that's what makes it a matched pairs design, because we're randomizing within the pair or within the student. All right, next example. I'm interested in finding out if students think that toilet paper should come over the roll, under the roll, or if it doesn't matter. I obtain a list of all ACC students. Using a random number generator found on random.org, I select 100 students. Out of the 100 students selected, only 85 can be contacted. And sorry, my bad on repeating the last sentence, so just pretend that's not there. All right, so first thing we decide, is this a sampling situation or is this an experimental situation? And in this case, we're not applying any treatments, we're just asking students what they think. So this is an observational study, so we're looking for which type of sampling design that we're going to have. So we had those 4 we talked about, the simple random sample, stratified, systematic, and voluntary response sample. In this case, we have a list of all ACC students, and we're just randomly selecting students to be in our sample. So this is going to be a simple random sample. There was no grouping, there was no interval selection, so that's what makes this simple random sample. And we did use a random method, so that makes it not a voluntary response. Keeping going with this same problem, let's talk about what the population and sample are for this particular study. So the population is the entire group of interest. So I was interested in finding out if students think what they think about the toilet paper roll. So I obtained a list of all ACC students. So my population is all ACC students. Now the sample is the subset of the population that we actually measure. So in this case, I took the list of ACC students, I randomly selected 100 students, but out of those 100, only 85 were willing to talk to me. The other 15 hung up the phone. I mean, imagine that. Have you ever done that before? Hung up on a survey person? So the 85 are the ones that I actually measured, meaning that my sample, it's not the 100 that I randomly selected. That's what I wanted to be in my sample. My actual sample is the 85 students contacted. All right, one more example. A researcher has developed a new pain medication. He wants to see if it's better than Motrin or Vicodin, 2 commonly used pain medications. He finds 60 subjects who want to have their wisdom teeth removed in exchange for participating in this study. 20 subjects are randomly assigned to each of the 3 medications, and their level of pain is monitored. All right, so first thing we decide, sampling design or experimental design. In this case, we have a treatment that we are applying to the subjects. We have this pain medication. So first we're going to cause our subjects a whole bunch of pain by yanking out their wisdom teeth, and then we're going to give them the treatment, one of these 3 different pain medications. So this is an experimental design. So now we need to decide between completely random, block, or matched pairs design. And it goes back to how we're randomizing the treatments to the subject. In this case, we have all 60 subjects. We're taking all of them and randomly assigning them to the 3 different treatment groups. So this is a completely random design.